Hello Algebra 1 students, here's our video on box and whisker plots. I know it's super duper late. I said I would have them up much sooner than this, but my whole family of 3 got the flu, and I was sicker than I've been in 10 years. And then as things were starting to finally look up on Christmas Day, I realized about halfway through the day that our refrigerator was no longer keeping our food cold and was dead. So it's been a week of being super thankful for simple little comforts like electricity and refrigeration and not feeling like we were all at death's door. We were really sick. Stay away from this flu, children. Wash your hands. In fact, pause your video right now and go wash your hands. And then you can come back and learn about box and whisker plots, which actually has nothing to do with kitties, but I thought this image was so darn cute I had to put it in the video. So I've wasted a whole minute almost telling you about my break. Let's jump in and learn box and whisker plots again here, folks. Okay, so it's a demonstration, or it's a way to display something called the 5-number summary. And a 5-number summary involves these 5 numbers for a set of data. The minimum, which is the lowest value in the set. The maximum, which is the highest in the set. The median, which you already knew about from last year. The middle value, actually probably more from like 5th grade. The middle value in a set. The lower quartile. The lower quartile is the middle of the bottom half of a set of data. The upper quartile is the middle of the top half of a set of data. What the quartiles do with the median, and sometimes the median is actually even called the second quartile. In fact, some of these are slightly different. Like you can call this the second quartile, and you can call this one the first quartile, and then this one is the third quartile, and that puts them in order, least to greatest. And what they do, the 3 quartiles, is they take that data. Think of this rectangle as being an example, a demonstration of that set of data. Those quartiles split it into 4 equal parts. First quartile, second quartile, third quartile. So that's the 5-number summary. The minimum, the maximum, the median, lower quartile, and upper quartile. And the great thing about you having a TI-84, TI-83 calculator is it actually finds those 5 numbers for you quite simply, and I'll show you that again in class, but let's look at how we display the data from a box and whisker plot. Alright, uses a number line and that 5-number summary to show dispersion of a set of data. Dispersion, how spread out the set of data is. Okay, so the first things first here, I've got to take these numbers that I have in this set. I want to find out how many I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. That helps me a little bit figuring out where my 5-number summary values are. So let's put them in numerical order. So it looks like we have a 2, we have a 3, we have a 4. 2, 3, 4. We have 2 7s, an 8, a 10, 11, and a 14. 10, 11, 14. All right, the middle number, well, in this particular set, since you have 9 numbers, the middle is actually the middle number, so it's the 5th number. And we can tell that because 9, when you divide 9 by 2, 9 divided by 2 is 4.5. So that means that you round that up, you're looking for the 5th number. And that's actually how you can always find that median when you have an odd number of values. If you have an even number of values, so say there was a 10th number, you would actually look halfway between the 5th and the 6th value on the list. So that's how you find the median. It's either the middle number if you have an odd number of values, or it's halfway between the 2 middle numbers if you have an even number of values. So in this case, my median is 7. Now for the lower and the upper quartile, you do the same thing as the median, but what you do is you look at the bottom half of the data and the top half of the data. So I've underlined the 2, and you find the middle. Well, since each of those sets right there, those subsets of the numbers, only has 4 numbers in it, you look halfway between the 2nd and the 3rd number, right there. So halfway between each of those, well, you have halfway between 3 and 4, and halfway between 3 and 4 is 3.5. And over here you have halfway between 10 and 11. Between 10 and 11 is 10.5. Okay, so now you have your 5 numbers because your minimum and your maximum, well, you don't even really have to do any thinking for that. those are just the lowest and the highest number. So minimum, maximum. So your 5-number summary in this case is the minimum, lower quartile, median, upper quartile, maximum. So the next thing you do is draw a number line. Now your number line is a straightforward number line. So, all right, the lowest number on the number line is a 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 is the highest number on there. And I can put one more notch just so that it doesn't look quite so naked. Now you can put every number in there if you want to, 2, 3, 4. I'm just going to put every other so that it doesn't get so crowded that I can't read my own situation here. Now that you've done that, now put a dot at each of the 5 numbers in our 5-number summary. So we'll put a dot at 2, and I like to float mine above like that. We're going to put a dot at 3.5. We're going to put a dot at 7. We're going to put a dot at 10.5. And we're going to put a dot at 14. And so the next thing you do is draw a line all the way through, and then a box that goes from quartile to quartile, and a line down through the median. Oof, that's messy. Sorry. And that is a box and whisker plot. It should be a little bit more even, but you know, it's not going to be perfect. When I say even, I just mean the actual drawing of the box. Now notice that these individual parts of the box are not going to be even. That is about the dispersion of the data. So it's not going to be a symmetrical thing that you draw. It's not going to be symmetrical, not all the time, sometimes, but not all the time. But what it shows is the dispersion of the data, and this data is pretty evenly dispersed. You notice that it's a little bit tighter in here than it is over here. Now, again, they're quartiles. Think about the word quartile. Real quick, let me write the word. Quartile has the word quarter, or has the affix, suffix, prefix, I don't know, stem, let's go with stem, quart, which means fourths, or breaking into fourths. Well, that's what you have going here. If you look at what you've got in this box and whisker plot, half of the data is from the median down, half is for the median up, and then each of these sections represents half of that. So you have 25% in each of the 4 sections that's created by the quartiles. Even if it doesn't look even, that's where 25% of the data is. And there's all kinds of different questions that we're going to have to answer based on that kind of information. So let's look at some examples of that. All right, and just to real quick to recap in terms of the organization of the box and whisker: lowest value, highest value, lower quartile, median, upper quartile, and then you have this thing right here called the interquartile range. The width of the box, and that would be your upper quartile minus your lower quartile, gives you your interquartile range. And what that is the middle 50%. Because remember, if you've got 1/4 in each section, you can have a middle 50%. So you can have the lowest 25, the highest 25, and the middle 50. You can use those percents to answer all kinds of different questions, but we're just going to look at some general box and whisker plot questions. Now, you do not have to copy everything word for word here, but it would be a good idea to understand what you're looking for when you're answering questions about a box and whisker plot. Now, these were multiple choice, but I took out the multiple choice part of them because they're not difficult. What's the value of the 3rd quartile shown in the box and whisker plot? Well, again, remember, 1st, 2nd, 3rd. So in this case, it's probably 10. Let's make sure we are counting by 1. 6, 7, 8, 9. Yes. So in this case, it is 10. Number 2. The box and whisker plot shown below represents student scores on a recent English test. What's the value of the upper quartile? Well, again, 1st quartile or lower quartile, median, upper quartile. Well, let's look at what are we counting by here. 82, 4, 6, 8, and then 90. Let's see, 80, we'll go with 84. 84. There's your upper quartile right there. So you're looking both at the location on the box and whisker and at how are we counting on our number line. This one also counts by ones. We're looking at the median score. We're looking for the line through the middle of the box. This one was scores on a math test, and that's an 81. So again, not difficult to read. the box and whisker plots, just got to know your parts. You can also look at the percentages. Now let's get one more median question in here. I don't like skipping around. That was number 4, so I went ahead and kept 4 in there, and then 5 and 6 are percentage questions. But median, again, one more time. So this one's counting by 5s. Median is right in the middle of the box, 75. All right, now look at this one. Box and whisker plot represents math test scores of 20 students. So there's 20 kids on this box and whisker. Now, I could actually lay them out and figure out where they are. Like, I can figure out whether or not one of those 20 is the median. It is not, in fact, because you have 20, that's even. So you have 10 above, 10 below. So that median is actually not even one of your values in your set. Now, we'll come back to that in a minute with a much more complicated problem. But let's look at percentages. 1/4, 1/4, 1/4, 1/4. 25%, 25%, 25%, 25%. So when they ask a question like this, what percentage of the test scores are less than a 72? Here's 72. Less than a 72 is just one of the 4 sections. So that's a 25% of the scores are less than 72. Look at this box and whisker over here. This has 12 people in it. What percentage of these people are age 15 or older? So again, box and whisker, find your 15. Now 15 is here, it's the lower quartile. That means you got this 25%, this 25, and this 25. So what percentage of people are 15 or older? 75% of the people in that, whatever that set of people, the set of data was, are age 15 or over. So you can tell based on that box and whisker. And that's the whole point of box and whisker plots. I have actually seen them in scientific journals. I went to start looking for some examples and had a very hard time actually finding something that I felt comfortable taking a screenshot of and putting in a video, because people get a little upset when you use their work in that manner. But maybe I'll try and show you some examples online in class. Okay, so this is actually an example of where these box and whisker plot questions kind of go off the rails a bit. They're possible to answer, but they're very confusing. So what I want you to do here is I want you to bear with me. We're going to read through the question together, and I'm going to show you how you answer this. And I will try and do a whole bunch of examples like this in class. So this is an SOL released question from the state, by the way, of course, because you can tell kind of from the way it looks. The number of points to, did not mean to be using the writing tool. Let's fix that. Okay, sorry. The number of points 2 basketball teams scored is summarized in the box and whisker plot. So here's Team A, much bigger dispersion. So they had really good games, and then they had at least one really bad game. And then here's Team B, a little bit closer together, a little bit more consistent of a team, but they didn't have as good a game or as bad a game as this other team. Team A scored a different number of points in each of 14 games. So that's the first thing we got to know here, is that we are breaking up 14 games in Team A's box and whisker. But in Team B, we're only looking at 13 games. 13 games. They want to know the total number of games that Team A and B scored 55 points or higher. So 55 points or higher puts us right here. 55 or higher. So we've got to figure out how to break this up. How to break these 2 sets of data up onto the box and whisker. And it actually matters that you have an even and an odd. So let's start off by, it's a little bit time consuming, but bear with me. I'm going to draw out 14 X's. And we're going to look at where the median, the quartiles, and so on. Let me pause it to do that so I'm not wasting video time here. Hold on. Okay, 14 little X's all in a row. I'll switch a color again here. Now, 14, so that's even. So that means that 14 divided by 2, our median is between the 1, 2, 3, 4, 5, 6, 7th, and 8th number. Our median is not one of our data values. But there are 7 X's on either side. So there's 7 numbers lower than the median and 7 higher than the median. And I know what the median was. The median was 60. Now look at where the quartiles would be, because we've got to find that lower quartile. Now if you look, there are 7 values in this bottom half. So the middle of that is one of those values. You got 3 on each side of it, and there's 1 in the middle, and that is the number 55. Okay, so we've now figured out how many in Team A scored 55 or higher. We just got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total out of that first team. Now you're going to do the same thing with the second team, and I want you to try it on your own. Draw out your 13 X's. Find where the median was. Count the median and up, because that is where you had 55 or higher. I'm going to pause it and draw my 13x's. All right. And again, switch colors. So, where's the median this time? Well, this time there's only 13 instead of 14. That's odd. That means you're going to have a middle value. So 13 divided by 2 is 6.5. The 7th value is my middle value. So 1, 2, 3, 4, 5, 6, 7. That one right there. Right there. And that's the number, the median, 55. And we want 55 and up. So again, count them. 1, 2, 3, 4, 5, 6, 7. So there are 7 from the second team. If you add those together, there are a total of 18 that scored 55 points or more. So yes, that is a ridiculously complicated question, but it allows you to take what you know about box and whisker plots and apply it a great deal. All right, I hope I haven't bored you too much, and Happy New Year. If you notice, I'm going to go ahead and actually upload this one and then probably one late tonight, New Year's Eve. Have a safe and happy New Year, and I will see you guys in class.